Okay, so in today's video we're going to start Unit 4, Topic 2, Reducing Balance Loans and Investments. So today's lesson is about using the recurrence model for reducing balance loans. So here are the syllabus descriptor that we're going to use. So it's use the recurrence relation where AN plus 1 equals R times A to N. Take away R, where R is the monthly payment, to model a reducing balance loan. So what is a reducing balance loan? It's a type of compound interest loan where the loan is repaid in regular payments and the interest paid is calculated on the amount still owing. And so each month, because you've made a payment, the balance is getting lower and lower until you've paid it off completely. So if you remember from Unit 3, a recurrence relation uses the next term is the term before it multiplied by the interest rate, and we take away the repayment. And this is where we started. So that should be familiar to you after finishing Unit 3. So I'm going to take an example. So Jeffrey borrows $3,500 at a rate of 6.5% per annum, and the interest is compounded monthly. It's going to be paid back in monthly instalments of $711.43. So the question says, write a recurrence relation to describe the situation, and then use the calculator to determine the number of months required to pay off this loan. So here's our starting balance. Here's our interest rate. So 1 plus 6.5% divided by 12 because it's compounded monthly. Here's our repayments. Here's the general formula for the recurrence relation. And here it is where this is our interest rate. This is the amount that we started with. And this is what we're taking away. So how do we do this? We press $3,500 on the calculator and press enter. Then we multiply by 1.00542 and we take away our payment. And we keep doing that until there's a zero balance. So let's start. Oop. So obviously, here we are, 3500, press enter, then multiply by our interest rate, 1.00542, take away our payment of $711.43, 1, 2, 3, 4. So after 4 payments, we have a negative balance. We can also use amortization tables to calculate how much is required on a loan. So amortization table tracks the step-by-step basis. So we start with what our payments are, our interest, which is the percentage times the payment, take it away from our principal, and we work out the balance of the loan. And as you can see, in the fifth one, we had 2 cents. So So Sufen borrows $550,000 at 4.5% per annum to buy a house compounded monthly. She's going to pay it back in $3,800 installments, complete the amortization for the first 3 payments. So here's our general formula, and here are our payments for the first 3 repayments. So now it's time for you to do some independent practice. So I need you to go to page 271 of your textbook, complete the questions, and then go to study on your online textbook. Once again, make sure you end any previous sessions before you start, and click the tick sign to start. Now, the next slides are going to have the answers to these questions. So I would like you to have a go at doing the questions before moving on to the next slides. If you are stuck and don't know what to do, or you've done the questions and want to have more explanation of the answers, then feel free to follow on, but at the moment, pause the video. Okay, so I assume that if you're watching that you've done the questions on Study On, and you now want to see how to do it, or you got stuck and you want to see the answers. So here's the first question. Interest is charged on a loan, $75,000 at a rate of 0.7% per month. The monthly repayments are $725. How much of the principal is outstanding after 2 months? So here's our recurrence relation, 75,000, 0.07. Here's our payment. So 1 month, 2 months. So on our calculator, put in the 75,000 times 1.007, take away our payment, 1, 2. So our balance is $74,598.60 after the second month. So that would be answer D. Next question. Austin takes out a loan, $5,000 at an interest rate of 6% compounding monthly. He makes $200 payments each month. What is the balance of the loan after 3 months? So first we write our recurrence relation, and then we work out the balance at the end of the first month, second month, and third month. So 5,000 into the calculator times 1.005, take away our payment of $200, 1, 2, 3, and there's our $472.37. Question 3. An interest-only loan is a loan where the payment made at the end of each month is equal to the interest accrued during that month. Calculate the payment required for an interest-only loan of $20,000 at an interest rate of 10% per annum compounding monthly. So we're going to write our recurrence relation, and we have to work out what our payment is going to be. So at the end of our first month, we have an outstanding balance of $166.60. So for the loan to be interest only, we need to pay this amount. So the interest is the balance take away the principal, which is $166.60. Question 4. Jane and Hashim have been paying $2,500 in monthly installments towards their home loan. At the start of the month, there is $70,000 still outstanding on their 6.3% per annum loan. How much the principal will be still outstanding at the end of the first month? So We write our recurrence relation, and we work out the first month. So at the end of the first month, $67,867.50. So here we use our calculator, enter A1 times 1.00525, take away our payment, 1, and here we see $67,867.50, which is answer C. Question 5. Interest is charged on a loan of $25,000 at the rate of 0.8% per month. Monthly repayments are $225. How much the principal is still outstanding after 2 months? So we write our recurrence relation, 1 month, 2 months. So we put in our 25,000, we times by 1.008, take away our payment of $225, 1, 2. So our answer is $24,949.80, which is answer A.